And now we're going to move on to example 4. So now let's talk about the intermediate value theorem. Let's say we have a polynomial function, and if you determine what f of a is and f of b, and they end up having different signs, we'll say one's positive, one's negative, then that means there is a c somewhere between a and b where f of c equals 0. So let's see, what does that really mean? Okay, well, if you'll take a look at the graph here, you see an x we've labeled a and another x value we've labeled b. So f of a, that point would be a, f of a, right? And f of a is the height of the function there, and that's a positive number, right? Okay, let's look at this function again. This point right here would be b, f of b. Well, the height of the function there, f of b, has to be a negative number, right, if we're in that quadrant. So we realize, oh, if we go from a positive to a negative, that is definitely a sign change. We definitely have opposite signs there between f of a and f of b. So that means there's somewhere in here where there's a c. That's what they're talking about. And f of c equals 0. So we could say c is a root, but we could also say that c is the x-intercept. Okay, so that's what we use the intermediate value theorem for. Okay, so example 4, we're going to use this intermediate value theorem. Here's our polynomial function, f of x equals 3x cubed minus 10x plus 9. And we need to show that there's a real 0 somewhere between -3 and -2. Now, they're not asking us to find the 0. We're just having to say that there is a 0. So, evaluating for f of -3, you'll end up with -42. When we evaluate f of -2, you substitute that in and work it out, and you'll get +5. We notice we go from a negative at this value when x is -3 to a positive when x is -2. And so, using the intermediate value theorem, we can say for the function f of x equals 3x cubed minus 10x plus 9. F of -3 equals -42. F of -2 equals 5. Since there's a sign change, that means the polynomial function has a real 0 or an x-intercept somewhere between -3 and -2.